Quality of service, or QoS. That's a topic that appears on Cisco's CCNA and Encore exam blueprints. And QoS is one of the more intimidating topics for students, but it doesn't have to be. Hi, my name's Kevin Wallace, and if you'll spend a couple of minutes with me here, I want to demystify two QoS concepts. Visualize a router sitting at the edge of your wide area network. You're coming in from your corporate network at a gig rate, and you're going out to the wide area network at, let's say, 100 megabits per second. Both fast links, but you've got a 10-to-1 speed mismatch. That means if you're just constantly receiving a gig stream coming into that router, there's no way it's going to be able to send all that traffic out on the WAN because it's coming in 10 times faster than we can send it out on the WAN. So what does a router do? A router is going to allocate some memory called a buffer or a queue, and it's going to try to store those packets up temporarily in hopes that bandwidth demand is going to die down, and in a moment we'll take those packets out of the queue and send them on their way. Now let's imagine that a queue is like this glass, and we've got traffic coming in, and the queue is only so big. After a while it's going to start to overflow, and it's overflowing for both voice and video, really important traffic. Everybody's getting dropped. So check out what we can do with queuing. With queuing, we can take that one queue that the router has on the interface, and we can divide it into, let's say, two queues. I've got a queue for voice over IP, and I've got a queue for everything else, as an example. And let's say here comes the traffic. We've got a lot of traffic coming in for just web traffic. People are streaming video. Got a little bit of voice over IP, lots more web traffic, a little bit more voice over IP. Network gaming is going on here. And suddenly the catch-all queue, it's overflowing. Meanwhile, the voice queue is not. There's still room for other packets to come into the voice queue. You see, by doing just basic queue separation, we have protected our voice traffic. But there's still an issue with what we talked about. What we've just talked about is something called class-based weighted fair queuing, or CBWFQ. That's a way for us to take that queue space and divide it in to all these different classes of traffic. Now, Cisco recommends that we should have no more than 11 classes of traffic that we create. But with this queue, let's say that it fills up and we're wanting to send it first ahead of the other traffic. We want to give it priority treatment. Well, if this voice queue, or whatever we're putting in the high priority queue, is full, imagine what's going to happen. If it gets to go first, it's going to go and go and go and go and go. You see what's happening? We're delaying everybody else. We're giving priority to the voice at the expense of everybody else. We don't want to do that. So what we're going to do is something like a carpool lane. Imagine you're in one of those large cities that have a carpool lane. You've got the diamond lane, and if you're in a vehicle with two or more people, you're able to get over in that other lane and kind of zoom past the other traffic, just kind of sitting still. But it's not the Autobahn. You cannot go just as fast as you want. That's what we have with LLQ, low latency queuing. With low latency queuing, we can have a queue for voice, as an example, or video, but it's going to have a smaller limit. It's going to be capped. So we're not going to be able to just completely overwhelm and starve out our other traffic. So back to our scenario. Let's say that I've got some general purpose traffic. I've got a little bit of voice, maybe some video, general purpose traffic, a little bit more video streaming, a little bit more network gaming, and a little bit more video. Now notice what happens. My priority queue, as it's called with low latency queuing, it's full right now, so I cannot send any more than that. And can you see the difference? By having a queue with a cap on it, that's going to prevent me from starving everybody else out. And that's what low latency queuing does. It gives us priority treatment. It lets us go first. We can send our voice or video traffic first up to a point. It's not going to send more than we tell it to, so it's not going to starve everybody else out. And that's just an example of two QoS mechanisms. Class-based weighted fair queuing, where we're not giving priority treatment, but we're giving different amounts of bandwidth to different applications. And low latency queuing, where we are giving a priority queue to our important traffic, like voice or video, but we're setting a speed limit on it. We're doing something called policing. Now, if you want to see how to configure those two tools, in addition to learning every single QoS topic on the CCNA and Encore exam blueprints, I'd love to invite you to join me for free, and we're going to cover every QoS topic you could possibly want to know for either of those exams, and then we'll even go a little bit further in QoS. Here's the deal. I'm recording a QoS masterclass that I'm going to be selling on my website later on, but I thought as long as I'm shooting the class anyway, let me just invite some people to watch behind the scenes. So you can attend, no replay obviously because I'm creating an actual course here, but if you want to just attend live and watch behind the scenes, you're welcome to do that. You can watch me record this entire QoS masterclass at absolutely no charge. It's all happening November 4th, and it's going to be at 2 p.m. Eastern Standard Time. Eastern Standard Time, that's GMT -5 if you want to adjust for your time zone. Thanks a lot, and I hope to see you in the free masterclass.